I am doing this for myself anyway. I will remember it next time. Okay. So this one is recording. Let me see. Yeah. Okay, so hourly employee is an employee actually, and it has two more data members, private data members. And I get the setters and getters for those, and of course print check I didn't like. This time my constructor has 1, 2, 3, 4 parameters, because these two are for the employee, these two. Okay, the other two are the wage, hourly wage, and the hours, number of hours. It belongs to me. They belong to me. Okay, good. So implementation, well, I mean, let's look at it. Is easy. Constructors are the same. The rest is getters and setters, and the getters and setters. And let's not look at this one right now. Okay. Ignore that one. That's a bad thing actually. So I set my pay. My pay is, remember the net pay of the base class employee. I set it to hours times the get wage rate, and print hours and print the get net pay, and that will be it. Well, actually, you know what? This is not true. Employee print check. Do I have my employee header, and where is my employee class? So what I am saying here is actually, let's change the employee function in a way that, okay, let's change the employee function in a way that no, I'm not going to go to that. Sorry, I will come to it later maybe. Okay, I'm not going to change it. Sorry. Go to this and let's fix it that way. Okay, so my salaried employee will work this way with the print. My hourly employee will work this way with the print, get hours, get wage, and get net pay, etc. And this will be the whole thing. And if I do this, okay, hourly employee is just an employee, but it's an hourly employee. I use a set name. Remember, set name, set SSN, okay? These two come from the base class employee, but these two come from the class hourly employee. Okay, and the salaried employee, I can do everything that I like with the salaried employee. For example, get name here. Okay, get name is here. It comes from the base class. Of course, the print check, this print check and this print check are different. One is a print check from the hourly employee, one is the print check from the salaried employee. Okay, so that's basically it. So I'm using these two using statements. Okay, any questions about these three classes? So this is the picture. Usually we start writing this kind of code, we draw this picture first. Okay, whatever we did, as I said, this is a UML diagram. It's very commonly used with the object-oriented programming environments. Let me show you this most popular UML hierarchy diagram that everybody kind of knows. Okay, this is Java collections UML diagram. Okay, this is basically this is good. We will see this later, but for now let's look at this as an example. Okay, so at the top of this hierarchy we have this iterable class. They are not classes, but we are going to call them classes. Then I have my collection class. From the collection class I have this set class. Set is, as you know, your midterm question and your homework question is just a class. List is another class. Q is another class. They all derive from this collection class. Okay. Under the set, there is this sorted set. Usually, you don't keep your elements in a set in a sorted way, but sorted set is a set that keeps its element in a sorted way. Okay. And there are other stuff. What else can we look at? Okay, this is the interface stuff. Okay, and we have our Q and DQ and sequential list. Okay, so our vector in Java is actually a list. There is another list called array list. Okay, our tree set is a set, but it is kept as a tree. Okay, so this is given to you. Okay, when you look at the Java stuff, what does that mean? If you have a vector object in Java, okay, whatever is defined inside this collection belongs to you too. Okay, if collection has, give me the next element of this vector function or method. Okay, vector has it too, and array list will have it too. Okay, so all these common stuff between all these classes will be collected under the same roof. Let me, this is a simplified picture actually. The real picture is more detailed, more complicated, and maybe this one is a little bit better. Yeah, well, this one skips some of them actually. And let me show you this one, and let's go back to the C++. C++ libraries, STL classes, they don't use inheritance much. It is available, but they don't use it much. Okay. For now, implements and extends are the same thing as for us, as inherits. Okay. Collection is here. List is here. Array list and vector are examples of this, or the derivations from the list. There is a queue, and it looks like this linked list. Okay, it looks like this linked list is both a queue and list. So there is a multiple inheritance going on. We are going to look at it this week about the inheritance. Okay, good. So this is a set class here. Hash set, sorted set, linked hash set. Maybe there is a link from this to that. I don't remember. As I said, these are all simplified pictures. Let's go back to this one. Why am I showing you these classes, these hierarchies? I am showing you because I told you that, okay, when you write these kind of it's gone. What happened to my I wonder if it is because oh. What are we gonna do? Did you get it? No? Okay, let's use my phone connection. I think because of the storm we keep losing. Am I connected? Yeah. Where am I connected? Okay. Okay, do you guys hear me, online people? Do you hear me?
Yes, we can.
Do you see my screen? You see my screen? Okay, good. So we are talking about this hierarchy because it's a common thing to show this hierarchy using this diagram, and it is very easy to see the relationship between the classes. And in fact, these kind of UML diagrams are very popular within the community of object-oriented programming people. And there are actually systems that we call, okay, case tools, computer-aided software engineering tools that will help you draw these kind of diagrams. Okay, you draw this kind of a diagram and you tell the case tool that write me the code for the employee class, salaried employee and hourly employee class in Java or in C++ or in C# or whatever programming language that you like to use. Okay, so it is easy to actually, I mean, it would be a one nice simple homework for you to get the employee, get this hierarchy from your client and produce the C++ code for this hierarchy. Of course, you won't be able to fill in all the functions, but it is very useful to write the function headers and function skeletons, and the rest of them, of course, belongs to the developer itself. Okay, good. So let's move on. We talked about the code. We talked about the inheritance of object-oriented programming. It's a very powerful programming technique. Okay, provides abstraction dimension called. Okay, we are doing abstraction through inheritance. Okay, so what we do is we write the general form of a class, like the employee class. Okay, we write the general form of it. Later we add specialized classes like the hourly employee or the salaried employee, or we write the special class or the generic class collection or set. Then I write the sorted set and tree set. Okay, so these are specialized. Okay, the sorted set can do more than what set can do, but it's a set. Okay, the common code between the sorted set and the tree set goes to the set class. And most of the time we say that set is an abstract class. Don't make an object of set because that won't be useful for you. Okay, so instead use set as a base class for the sorted set and the tree set. Okay, it is okay if you write a function that takes a set reference like this. This function will work both for sorted sets, tree sets, and for set objects too. So that's what we mean. General form of the class. Set class is general form. Okay, tell me the things that can go into the set class. Add member, remove member, okay, intersection, and etc. How about the sorted set? Sorted set is a little bit different. In the sorted set, you have your first element, next element, and next element, right? It doesn't make any sense for the set to have the first element. Okay, set doesn't have a first element. Set have elements. How about the tree set? Tree set keeps its data in the tree form like a binary search tree. So it is very easy to make a search on this tree set. Okay, but the common stuff between these two is inside this set class, and that's the general form of the class. And then later we add to it, we modify its functionality for appropriate use. That's what we said. Okay, so we talked about this base class and the derived class. Okay, this new class inherits everything. There are some exceptions, but it inherits everything from this base class. Okay, and it's a new class, but it automatically has base classes, all the variables and all the functions. It includes by all the variables. We mean it includes all the public and private data members and member functions, public and private member functions. And later I can add more member functions, more member data, okay? And if I don't like, I can change the behavior of some of the functions. I say that I don't like this print check anymore, okay? I will write new print check function for you. So I'm going to redefine it. It's called redefinition. Redefine. We will come back and we'll talk about this. This is important. Okay, derived classes. Okay. We talked about this, right? Each is a subset of employee. Whatever derived class you introduce to the employee, it will be a subset of employee. Employee is the generic one. So we may think this like a constant day of year. Well, it is not like that, but I mean, you may think it like this. And this is just day of year. Day of year. Okay? So this constant day of year class has only constant functions. It doesn't have set day, set month. It has only get day, get month, and maybe the print function. That's it. But day of year has all of them. Get and set. Okay. Did I say set? Sorry. This one has only gets. Why don't I write this? Why don't I write this using the UML stuff? Okay. This is my constant day of year class. Okay. Inside it, in my private part, I have a day, which is an integer. I have month, it's an integer. Of course, I have my day of year constructor. It takes two integers. Of course, I have my get day, which returns an integer, and of course, I have my get month. It is an integer. So this is constant day of year class, and I have another class, okay, non-const day of year. This non-const day of year has, what are my private data members for the day of year other than constant day of year private members? What are my private data members? No, yeah, exactly. No, I mean, I don't have to introduce anything new. I don't have anything new because I have all the data that I need in here. But I will do this. I will say, of course, constructor day of year, integer and integer, and plus set day, okay, and set month. Okay, so this day of year objects has four functions, two setter and two getter, but constant day of year class has only two functions, get day and get month. Okay, so it's kind of like that. If you think about this, if you think about this, this example is not turning out to be a very good example actually. Okay. If you think about this, okay, no, no, the naming is definitely too. Naming is not definitely. No, well, I think this is too early. Let me change. Okay, I made a very bad mistake. I will try to. I hope it did not confuse you. I will try to fix this mistake by renaming these. Okay, this is mutable day of year. Okay, this is non-mutable day of year. Day of year. Okay. No, this still doesn't fix it. Well, I mean, I was going to try to I was planning to try to connect it to the Java way of looking at the constants when the time comes. But this, why don't we just ignore this picture when the time comes when I start talking about Java? Okay, I will come back to this picture. So ignore this part for now. Okay, sorry, because it will take me at least 15 minutes to talk about it. Let's talk about the subset stuff without ignore with no let's ignore this part. Let's talk about the subset stuff. By subset, all I mean is this actually. Okay, all I mean is this. Employee class is the more general class. Salaried employee and hourly employee are classes that are more specific, that are more specific to some purpose. That's what we are doing. Okay, so salaried employee and the hourly employee are subsets of the employee class. And sorry about this example. Okay, that's not a wrong example, but it was a wrong time. Sorry. So derived classes, okay, they don't repeat themselves. They say that, okay, I'm same as the employee. I put some more meaning to it. We talked about this. They have all the names and etc. But let's talk about this since it is about the time. Let's go to this salaried employee, or better yet, yeah, salaried employee print function. Say this salary is my private data member, right? Instead of saying get salary, I am just using its name. How about this name? Why don't I use the name directly? Because I have inherited name from the base class employee, but I am not using its name directly, right? The reason is, okay, this is a bad thing to use the private data members directly, because I told you to use the getters all the time. Okay, whenever you can, use the getters all the time. Whenever you can, use the setters all the time. Maybe they are following this rule, but it is not actually. If I try to compile this program, line 40 will produce me an error message. It will say that name is a private data member of another class. You cannot access it directly. Okay. Well, you might say that, well, salaried employee is an employee class, and it inherited everything inside the employee. That's true. That's true. I have inherited everything from the employee class. That's true. But that doesn't mean that you can modify the private data member of another class. Okay, the private is private. That's it. No exceptions. What is the rule for the private? Private functions or private data members can only be accessed within that class only. Doesn't matter if you are some other class. Doesn't matter if you are a derived class from it. Okay. You keep data in you. Okay. As a salaried employee, I have an employee object in myself, but I cannot access its private data members directly. Okay. I inherit it, but I cannot directly access it. That's why I have to do this get name. Okay. So private is private. I didn't say anything wrong about at the beginning of the semester when you say private cannot be accessed outside of this class. There are no exceptions to it, even for the derived classes. Yes?
So when we inherit some class from another class, can we change the methods?
That's what we are doing, right? This print check function is defined in the base class. Okay, and we are redefining it. We are changing it. This is what we are doing. Of course, that's what we said. When you do the inheritance, you inherit everything from the base class. You add new stuff, and if there are some functions that you don't like, you change their behavior. And print check a function that we didn't like, we change this behavior like this. But while we are changing its behavior, of course, I can use all the functions as long as they are public, okay? And I use the public interfaces. For this one, since salary is my data member that I have introduced in the salaried employee, I get to use its name directly, which is not a nice thing, but just to show you that this works that way. So let's go back. Okay. Okay. So the derived classes, we say that they inherit everything from the base class. That's true. Okay. There is nothing wrong with it. You inherited everything doesn't mean that you have direct access to them in the case of private data and functions. Okay. So to use those private data, you need to use the public interface in your derived classes. Okay, employee class, talk about this. And we are not designing or we are not implementing this employee class to make objects of it. Okay? Employee is going to serve as a base class. Okay? What happens if you make an employee object? Well, it works. There is an employee object, but if you call the print check function of it, it will crash our program. It will say that I am terminating this program. That would be a bad thing, right? So that means that it is not our intention to use this employee as a instantable, a class that you can take the instances of. Okay, so we talked about this employee print check. Okay, and our purpose for the print check. Okay, question for you. Okay, this is a good question. Maybe if my intention is for the employee class, if my intention is to rewrite this print check function, and it doesn't make any sense, to implement this function inside the employee, why do I have this line 25? Just don't write line 25, okay? If you need a print check function, then just write your print check function in your salary the employer or the commission employer, whatever you need, right? Why do I have this line 25 inside this class employee? Because it doesn't, I'm not going to use it, right? If I use it for the employee class, it will crash my whole system. Why do I have this print check here then? I will take some 15 minutes of break. After we come back, I will ask this question again, and I will start from you, okay? Why print check? Let's be here around 10:38. I don't have the attendance. Sorry, I will bring it in 10 minutes, 15 minutes.
Hocam bir şey
Kim geliyor? Kim? Nereden geliyor? Gelen kim?
web servislerinde çalışan mühendisler altı.
Hocam yoklama döndü mü?
Sen dinlemiyor musun beni ya? Söyledim ya. Ne dedin? Gelmedi. Ders geçti. Bir sonraki ders geçti.
Hocam bir de Java ile ilgili bir şey soracağım. Siz biraz önce son bir tane resim çizdiniz mi?
Evet. 10 tane resim çizdim. Hangisi?
Mutable set ve unmutable set.
Ya onu ihmal edin ya.
Mutable list ile alakalı bir şey.
Ne?
Değil mi? Mutable liste benzetmeye çalıştınız.
Ne ki o?
Hani Java var ya, list mutable.
Ya sen onu ihmal etsene. İhmal etsen onu. Çünkü genelde bana Java sorusu soranlar Java bilmiyorlar.
Orada da uğraşıyoruz.
in order. Onun sonu belli. Okay, question. So why do we define this print check? Why do we define this print check inside the base class, since we know we are not going to use it at all for the base class? Yes.
I think it's not that we want to use it in the employee class. We're not going to use it anyway. And since it's both common among the subclasses of the employee class, like check, I don't know what was the name of the subclasses, either of them.
Hourly employee and salaried employee.
For example, we redefine it anyway, so that's my answer.
So we don't have to define it in the base class. So we redefine it anyway. That's what I'm saying. I mean, I know that it will be redefined. I don't like its behavior. Why am I keeping this line 25 here? Why do I need it?
Common among the subclasses.
So what is the use? It is common, I know, but I will not use it for the employee class. Why do I keep this print check here? Because I am going to implement it like this, exit 1. So it doesn't make any sense to keep this in employee. Let's remove this, and for the hourly employee, implement it. For the salaried employee, implement it, and we are done. So why should I remove it? And the answer is, of course, don't remove it.
Can I say something?
Sure.
I have two ideas. One of them, we don't use global function, and the other,
But they are not global functions, right?
yeah, the other one is we have
No, let's go back to global functions. These are not global functions.
Yeah, we don't use global functions, and for example, we have two objects from this class, and this class has print checks functions are different the other.
Yeah.
So we can override for these two objects. For example, we have employee and we have A and B objects, and each object has different print things.
Yeah.
So that we can override easily for.
Doesn't matter if you have line 25 in the base class or not. All you need to do is just write this print check and implement it. This doesn't make anything more easier for you to implement.
I think it's just a better interface.
Better interface? Why is it better?
More understandable, like overloading functions. Both have these functions. I mean, not mandatory this line. That's because I think.
Well, this line is very important. You have to have this line in here. It is as important as the class itself, employee class. I mean, we are not keeping this function because it might be useful, or it's kind of, yeah, it's okay, let's keep it there. No, it is very, very necessary line. Yes?
Maybe in the future we will have another derived class from the employee class, and it may not use, and we may not modify print check in here. But
well, remember this one, it crashes our system. Okay? If that class does redefine it, this function, then that class will be as useless as an employee class.
yes,
So, I mean, it is better not to implement it then. It is better not to have it then.
yes, but maybe user use another hardly employee class, and it may know print check, and it may want to use print check function, but we may not have another class derived class print check function. So we should have employee.
Then implement and define printf function for that derived function, whatever it is. You are saying that I am going to derive from this one, and I'm going to derive another one from this one. That's what you are saying. Yeah. Well, I mean, the same thing is valid for that class too. I mean, why do you keep repeating this stupid function that you don't know how to implement? Yeah.
Maybe to force the user do not use employee, because without with this print check, the programs shut down, and employee class is not useful.
Yeah, that's a very good point actually. I was not expecting that answer, but that's a very good point. By keeping this print check here in the employee, you are signaling the user that employee is not a class to be instantiated. It is not written for that, okay? You are saying that the employee is supposed to be a base class. You are going to derive from it, and you need to redefine this print check function, okay? That's one thing. The other thing is this, okay? Very closely related to your what you said. Remember, when I write a function, void. Am I connected to internet? Am I connected through my cell phone? Oh no. Oh, okay. This is coming. This is back. Okay, good. Remember this function f that takes a employee pointer p. What can I do with this p? I can say p set name a b c, right? P print check. What did I say? I said that for this function to work, salaried employee pointers will work, hourly employee pointers will work, employee pointers will work, but we don't use the employee objects anyway. But this function say that whatever employee object you tell me, it doesn't matter if it's a salaried employee or hourly employee, doesn't matter, this code will work, right? But for this code to compile and work, I need to have this print check, right? If you don't have print check inside this employee class, this code will not compile. True? Okay. This code will not compile if you don't include this print check function in your base class. Okay. So I am writing a generic code, function f, okay, which is supposed to work for the derived classes of this employee. I know that print check is not meaningful for employee class itself, but it will be meaningful for the future classes. Okay. So in a way that with the inheritance, okay, what did we say inheritance? Inheritance, I am inheriting everything that employee has, okay, including the data members and the functions and the function implementations, everything. In this case, I am inheriting only the interface, okay, interface of the print check. Okay, I am not inheriting, it is not my intention to inherit the implementation of the print check. My intention is just to inherit the interface of it, okay? If you are an employee class, if you are salaried employee, hourly employee, commission employee, whatever, okay, you have to have a print check function. Otherwise, this code will not be meaningful for you, okay? I have written this code. This code will compile. Once this code compiles, employee has this print check, okay? Once this employee has print check, all the classes that derive from employee has to redefine that print check. They cannot leave it as it is because the default meaning of print check doesn't make any sense. Okay? So inheritance has more meaning than just inheriting the data members and the function implementation, etc. It is more than that. Okay? Again, repeat the same thing. All we did is just a simple syntax addition, and there is a new, very large word in front of us. It talks about the inheritance, and it's a very basic principle, and we will talk about these kind of advantages and these kind of issues that might be interesting for us. Okay, deriving from employee class. Derived classes from employee automatically have all the member variables, including public and private. Okay, I inherit all of them. Even though I cannot access the private data members and private functions, I have inherited them. Okay, they are inside me, including all the member variables, all the member functions. Okay, and the term that we use is inherit. I don't know, some of you are telling me subclasses in C++, we don't have subclasses. Okay, in C++ we don't have methods. In C++ we have derived classes and base classes. That's the terminology for the C++. In Java, in other programming languages, it is different, but in C++, that's what we use. Okay. We can redefine the existing. Okay, that's called the redefinition. Existing function members. Oh, by the way, okay, this book says that you can redefine the existing members. It is wrong. Okay, you cannot redefine a member data member. Okay, you redefine only a function. You cannot redefine a data member. I had an integer in the base class. Now I am making it a double. That's not a good idea, and it is not allowable. Okay, you can't do that. Okay, you can't do that. So all you are doing is redefining your function. Okay, and you can add new function or data members. Of course, you redefine only functions, or you can add new function or data members. That's what you inherit. You inherit something. Okay. You inherit everything from the base class, including public, private, and etc. There are some exceptions. We are going to talk about it. And you add more new data, more new functions, or you redefine some of the functions that you don't like. Okay, we already talked about this. I will skip these. Employee class. Okay, we know those. Okay, this is the only new part. Okay, ignore this for now, and ignore this for the rest of your life anyway. This, I mean, there is, I mean, you can place a private here and some other keyword here, but those are not forms of inheritance and nobody uses them. I never use them. Those are not useful. Okay, employee class additions. We talked about these constructors and etc. We will talk about the constructors in a few minutes. Redefinitions, okay, this is called redefinition, and we will talk about it in a few minutes. Okay, inheritance terminology, let's talk about it. This is base class A, this is derived class B, derived class E. Okay, there is an is-a relationship between these, all of them. B is an A, E is an A, E is a B too. Okay, good. There is multiple inheritance. There is a multiple inheritance from B and C to E. Okay, E is both B and C. It's very useful sometimes. Okay, with the C++ there is some certain issues about this, but sometimes it's very useful. Let's say this is an employee class. Let's say this is a student class. So this is an employee student, a person who is both an employee and a student, right? So this student has GPA, get GPA, set GPA. This one has get pay, net pay. Okay, get pay, set pay. And this one has both set GPA and set pay, right? So that's very, very useful. This is multiple inheritance. C++ allows multiple inheritance, Java doesn't. We will talk about this. That's the terminology, okay?
Sir,
So these are the child classes. Yes.
you are not in the meeting.
What?
You are not in the meeting.
Really? Did they kick me out? I never. Am I recording? Yeah. Am I recording? But those people are not. Am I recording here? So that will be a interesting case. At the beginning of the class, I don't have the local stuff. Now I have the. Okay. So they waited until end of the class to let you know that. Okay, sorry for the
Your
not
mic is off.
what
Your microphone is off.
what
Your microphone is off.
my microphone is off. Are you guys? I am not sharing my screen. Let's share the screen. So they are hearing me now. They are seeing my screen, I hope. Okay, so for the people, online people, I spend 10 minutes of, or 15, 20 minutes of this time to talk about this question. Okay. Where is that question? Yeah. Why this print check? Remember that I asked the answer is you don't inherit only the data members and the functions, you inherit the interfaces too, and we need it. Basically, if you are writing such a function employee that takes an employee pointer, if I don't include this print check in my base class's interface, even though I cannot implement it, okay, even though I cannot implement it, to be able to compile these kind of functions, I have to have this print check inside my interface. And let me tell you something actually. In our next chapter, we will do this. We are going to say that, okay, this print check doesn't make much sense to implement it, so I am not going to implement it. So this means that I will not implement this function because it's a meaningless function for this class employee. But it is meaningful to have in my interface so that